Okay, so plugging our boundary conditions in, we get negative 0.02 divided by 2 times 250. Make sure you can see that. Equals V final squared divided by 2. Remember, this is all with respect to A. Minus 88 squared divided by 2. Okay? Now what we do is we pull our constants over to one side. So we write a little bit bigger here. So we have VF squared divided by 2 equals negative 2.5. That's what this simplifies down to. Plus 3872. Okay, we're going to multiply both sides by 2, so VF squared equals 2 times negative 2.5 plus 3872. That's going to give us 7739. And now we take the square root. VF equals 7739 to the 1/2 power. It's the same as taking the square root. And that equals 87.97 feet per second. So, it didn't slow down too much. The person probably was just coming to the intersection and just took their foot off the gas a little bit. Didn't know if they had to make the turn or not. But that answers our first question. The velocity of A at 250 feet is 87.97 feet per second. It only slowed down 0.03 feet per second, not much. But now the question is the velocity of B with respect to A at this moment. Well, what we're going to do is we're going to find the velocity of B equals the velocity of A plus the velocity of B with respect to A. Remember, the subscripts alternate, BA, BA, and the last subscript on the relative velocity is the one that's being taken with respect to. So you're sitting in vehicle A, how fast is B moving? So velocity of B with respect to A. Now, if you remember, vehicle B is going on an off-ramp that's at a 30-degree angle. So we're going to break velocity of B into I and J components, or we're going to put this whole equation in I and J, and then we're going to figure out the magnitude of velocity of B with respect to A. So velocity of B was 81 feet per second. Okay, and it's at an angle of 30 degrees, so cosine 30i plus 81 sine 30j, and this is going to equal, A is only traveling in the x direction, so it's going to be 87.97 I plus V of B with respect to A. Okay?